Okay, so today I am going to start a lecture series on this subject, computer organization. So this is our first lecture towards this lecture series. Okay, so let's get started. Okay, what is computer organization? What picture comes in your mind after listening this word, computer organization? Okay, so a computer organization is nothing but it is a subject which deals with the designing of a computer. Okay, how the various components of a computer system are put together to design a system that is capable of executing some instructions. So we have studied in our school times that there were mainframe computers, there were supercomputers, there were desktop laptops and all. So these computers are designed, because of this. How, why these computers are designed? Why not a single computer holds true for all the requirements? Okay, they were designed for some specific task, for some specific requirements. We can say for some specific requirements the various types of computers are designed to fulfill that specific requirements. Okay, so in this process of designing a computer, there were mainly two groups of people that were involved in this designing process. Who are they? They were programmers and designers. Okay, they were the programmers and designers. What programmers will do, what designers will do. Programmers will provide a requirement specification, will give a requirement specification to the designers that we are going to execute these types of instructions like 0 address, 1 address, or 2 address, and all. We are going to execute these types of instructions. Okay, so we want that much amount of speed. So according to this, designers will put various components. They put various components together and design a system and connect them and design a system that is capable of executing the instructions that were required to execute by the programmers. Okay, so where these people will talk upon what is the common topic between these two groups of people. What is the common topic? Okay, so they mainly discuss over that instruction set. What's the type of instruction set or machine instructions that is going to be executed on that system. So according to this, a system is designed. Okay, instruction set or machine instruction, according to this a system is designed. So some I will give you the picture of various various components of a computer are connected to how the instruction flows between these components. What's the role of a control unit, what's the role of ALU, what's the role of registers, and what's the role of a memory in this, and how the instruction moves from register to memory, memory to register, and register to registers and all. Okay, so let me draw a block diagram of this. this is our CPU, central processing unit. This is our CPU. Okay, so what are the components of a CPU? What are the components of a CPU? What is present in this CPU? Okay, so there's ALU that is present in this CPU. There's a ALU. There's one control unit that will be present in this CPU. Okay, there is one ALU. There is one control unit there, and there were registers. Okay, there is one control unit. There is one control. Okay, so there were registers that are also present in this CPU. What's the role of a registers? Data is moved in. Why we introduce these registers? Why we are, as a CPU, we are not interacting with the memory to execute instructions? Why we are not using that memory, as memory is huge? Okay, we know that memory is huge, but the speed of a memory the speed of a memory is not as much as the speed of a is not as much as the speed of a CPU. So there's a huge mismatch between the speed of a memory and a CPU. That's why we have introduced the registers to overcome this problem. Okay, that's why we have introduced the registers to overcome this. So the data is moved from a memory to a register. The data is moved from a memory to a register, and from that register the data is moved to the ALU in order to perform some operations, some required operations. Okay, why this is not happening? Okay. There were registers R1, R2 and all. This memory is not a part of a CPU. Some I think some are confused with that. Memory is a part of a CPU and all. Memory is not a part of a CPU. Okay, memory is outside the CPU. Memory is outside the CPU. It's not a part of a CPU. Okay. Oh, sorry. Memory is not a part of a CPU. So how the data moves from a memory to a register? Okay, so the control unit is responsible for that. The control unit is responsible for that. For it gives the control signals to the register. Suppose it gives the read signal to this and write signal to this register. So the data will move from the register R2 to R1. Okay, so the data will move from register R2 to R1 as the control unit gives these signals, these read and write signals to the registers. So the data will move. For one register it will give a read signal, and for one register it will give a write signal. So the data will move from the register R2 to R1. So the data will move from register R2 to R1. The data present in the register R2 will move to register R2. Okay, so likewise the data is moved from this memory to the registers, and through the instruction register the data is moved to the ALU for the processing. Okay, so I'll give the in the upcoming lectures I will give the whole picture. I will clear you the whole picture of this, that how a particular instruction is getting executed. So to be more specific, I will be explaining you in the in the upcoming lectures, that how the program that you write, how that is going to be executed and saved back into the memory. Okay, so what is the what are the types of instructions? I think you all are aware of this, that you know that what's the function of ALU, CU and memory. I think ALU is responsible for performing arithmetic and logic operations. Arithmetic operations like addition, subtraction, division, multiplication, and the logical operations like ORing, ANDing, inverting, etc. Okay. And what's the role of a control unit? The control unit uh, coordinates and control the activity amongst the functional units. These are the functional units. Okay, these are the functional units. These are the components. Okay, ALU and registers, these are the functional units. So it controls and coordinate the activity among among these functional units. Okay, and what's the role of a memory? You already know that. It's not okay. So what's the format of an instruction that we are going to be executed in our that is going to be executed in our system? Okay, what is the format of that instruction? In which format that is present, that instruction is present? Instruction is fetched from the memory to the instruction register first. Okay, and from that instruction register, that instruction is decoded, and according to the that instruction, the various the execution operation is performed. Okay, what is the life cycle of a instruction? Okay, we know that it is fetched, then execute, then it is decoded. Fetch, then it is decoded, and according to that instruction, according to that decoding, the instruction is decoded. According to it, the instruction is executed. Okay, execution, fetch, decode, and execution. This is the life cycle of a instruction. Instruction is first fetched, it is fetched into the instruction register IR, then it is decoded, and according to that decoding, the instruction is executed. Okay, so we are discussing the format of an instruction, in which format an instruction is present. We are discussing the format of instruction. Format of an instruction. Format of an instruction. Instruction format. So our instruction is mainly divided into the three parts. Okay, what are they? What are the one part is for the this is okay, one part is for the modes, which addressing mode we are going to execute. What are addressing mode? We will see that in our upcoming lectures what are addressing modes. Let's understand the addressing mode as how we are getting the data, how we are getting the operands from the memory, how we are getting the operands. Okay, that is that modes, addressing modes. Okay, what are addressing modes? It mainly deals that how we are getting that operands. Addressing mode. Okay, and then opcode. What are the opcode deals with? It tells that what are the operations that we are going to perform. What are the operations that we are going to perform? Like if we what are the operations? What are the operations that we are going to do on an operand? Okay, so like add, subtract, multiplication, branch. Okay, all these operations. And the third part is the operand. Third part is the operand, and it depends on the addressing mode, that how we are going to get an operand. We have various types of addressing mode. We will see in our upcoming lectures that we are having that direct addressing, indirect addressing, register, direct, register, indirect, and all. In the direct addressing, the address of a memory is present where our operand is residing. Okay, suppose in the operand part 100 is present. Okay, and we are talking about the direct addressing mode, and in this we have 100 in this operand part. So what it will do, it will reach out to the 100th location of our memory. It will reach out to the 100th location of our memory. Suppose it is 99 and this one is 100, and whatever the data is present at this location is going to be our operand according to the direct addressing mode. Okay, so we have and one more thing, it is totally depending upon the amount of money we are going to put in designing our system. Okay, if we are going to put more registers, then our system will be costly, and it will reduce spilling. What is spilling? Okay, spilling is nothing but spilling. What is spilling? For someone it will be a new term, that what is spilling. Okay, spilling is nothing but it's the wastage of a time in moving the data from one register to the another register. Okay, it's the wastage of a time. If we are having a lot many number of registers in our system, then the data will not move from this register to from one register to another register in order to be get executed. Okay, so that's all in this lecture, and next we'll discuss about the types of CPU organization. In the next lecture we are going to be discuss the type of CPU organization, and what are the advantages of addressing mode, and what are the various types of addressing mode. So what are the various types of addressing mode? They were implied addressing mode, immediate, register indirect and all. So these we are going to discuss in our new lecture. Okay, thank you.